We discussed about the basic idea used in the Knuth-Morris-Pratt algorithm for building the prefix automaton, and the agenda today is to develop from the point we stopped in the previous class to see how exactly we can construct the prefix automaton. So the topic today is a continuation of what we did in the previous lecture, part 2 of the Knuth-Morris-Pratt algorithm for string matching. We were trying to understand how that algorithm finds the prefix automaton. If you recall what we did in the previous lecture, we observed that the states of the required automaton are the lengths of the prefixes of the pattern. So, if the pattern is of length 9, 10 prefixes will be there, prefix of length 0, length 1, etc. until the length 9 prefix. So, while we are processing the input, we need to keep track of the lengths of the prefix of the pattern which you are finding in the text. Recall that we are finding the largest prefix of P, which is a suffix of the string processed so far from the input text T. In this example, the processed part is T7. And what is T7? Which is the first 7 characters of the array T is denoted as T7, or the length 7 prefix of T, which is T7. So, Pk represents the length K prefix of P, that is the notation that we discussed. So, at any point of time during the processing of the input string, what we have to keep track of is the largest prefix of P, which is a suffix of the string processed so far. Suppose the string is called X, then the suffix here must be X, the largest one. This is what we discussed already. Now, when you want to progress from here, there are two different cases. One is when you open the next symbol, it matches with the next symbol in the pattern. That is, the next symbol in T at index Q is same as the next symbol in P, which is at index K plus 1. That is case 1. In that case, what you can do? You can extend the matched string because the next symbols are also matching. For example, here they are matching. So, we can extend the matched string. Now it is X, you can extend it as Y. What is that? X followed by C. That is what I am trying to tell here. The new string will be Y, which is X followed by the next symbol in P. In this case, it is same as the next symbol in T. So, this is how you will do when there is a match. Now, look at the other case when they are not matching. For example, here when you open, you see that the next symbol that you are getting from the input string is small b, but in pattern you have a small c. So, they are not matching. So, what you can do? This is a critical stage in the processing. You cannot extend. Then you have to actually find the maximal prefix of P, which is a suffix of T8. Now you are extending the opened string because you just opened 8 So it should be the first 8 characters of T. So what will be that? For that we need to find a smaller prefix, say Z of P. It is not X, X is not the required one, because when you extend X with the C, you are not getting a matching with a suffix. So it should be a proper prefix of X, which is also a suffix of T7. In the previous stage, what is the next lesser prefix of X, which is also a suffix, right? This is what we are looking at. Now suppose you can find the proper prefix of Pk, call it as Z, which is also a suffix of T7. Then you have to see, okay, after Z here, if the next symbol is B, then that should be that suffix that you are looking at. For example, suppose this happens, then what you are looking at is exactly ZB. Okay. So what we are looking at is, we need to find a smaller prefix, say Z of Pk, which is a suffix of T7, is exactly what we are looking at. Now recall that what is this X from 1 to 4? It is the suffix of T7, which is also a prefix of P. That means this part and this part are same. From that you can see that because you have from 1 to 4 simples same as from here to there, the last 2 simples here must be same as the simples here, and that is because previously these are matching. So the last 2 simples or last n simples here must be same as the last n simples there, and that is the fact that we are using here. And so, and in a general case, this may not be like exactly dividing into 2. General case will be like this, where you have a proper prefix of Pk, which is a suffix of T7, and because T7 and this Pk have the same prefix and suffix, the sequence of simples in Z must be same as the last sequence of simples here. So you must have this here. So what we are observing is that Z must be a suffix of Pk as well. So actually you can define it in terms of the pattern itself. So we need a proper prefix of Pk. You call it as Pi, say in this case P2, which is also a suffix of Pk. That is what we are looking at. I hope you are getting me. Otherwise please watch it again, and for the interest of time let me proceed. So we can maintain this as a function called the prefix function pi. For every index here, it defines a number, and what is it? That number is the length of the string Z. Okay, examples can make it clear. The value of the function pi for k can be any value from 1 to 9. In general, m is the number of elements in the pattern. And what is the value? It is a maximum value from 0 to m minus 1, because you are looking at a prefix. So what is the largest length of the prefix? It is m, but if you are looking at a proper prefix, means less than m, then the maximum value is m minus 1. And what is that property of that value? If you are taking it as I, then the I simples here must be a suffix of Pk. That is what we are telling. So that Pi, that is the first I simples from P, that is a prefix of P, must be a suffix of Pk. That is, the same sequence must appear here as well. And if you remember the basic notations, that is prefix and the definitions for prefix and suffix, then this is not difficult. Otherwise please review or recollect what are prefixes and suffixes, then you can verify that what we are telling here is meaningful. So with this I am proceeding, and if you are not able to exactly see what I am telling, please watch it again. Now we can see how can you compute the prefix function pi that we have just defined. Recall what we defined. Pi is a function for every index of the pattern. You know that you will have q is the index that I am going to consider from here. Okay, q is any value in this index, and what is pq means the first q characters in p. Okay, and what can be pi q? Pi q means if you are looking at a pq like this, you take q as k, then you are looking at the maximal prefix of pk, which is also a suffix of pk. Okay, and that is the value that you need here. Examples can make it clear. Please don't get worried about it. Try to work out this example, and that can make clear what pi is meaning. Okay, in this p is the pattern and q is going to index the pattern. In this case there are 9 elements, so q is going to take values from 1 to 9, and pi is the prefix function that we want to compute. Okay, now let k be the length of the largest prefix, say z of pq, when you are proceeding in the pattern for q taking values from 1 to 9. Suppose you reached, say, at this point, then what will be pq? P5, which is the first 5 characters of p. So you want to find the largest prefix of this string, call it as z. Maybe if you are looking at BA, the largest proper prefix of this is BA, which is also a suffix. That is what we are looking at. Okay, if it is BA, then I am telling that k is that value. If you are looking at the first 4 characters BA, what is a proper prefix which is also a suffix? It is BA. Then 2 is what you are looking at as k. Okay, so to begin with, you have not processed any simple, so the prefix matched is of length 0, so k is equal to 0. And if you are looking at the first index q as 1, the proper prefix of this must be 0, because only one simple. If it is not proper, the prefix of b, which is also a suffix, is b itself, but not that. We are looking at a proper prefix that is of length less than 1. This must be 0. So I hope you are getting, because you have a string of length 1, proper prefix must be of length less than 1, and that must be 0. So you can initialize k as 0 and pi at 1 is 0. Now we need to compute the values of pi q for all values of q from 2 to m. Okay, in this particular example, the length of the pattern, which is m, is 9. Now you look at, you are going to take the next simple, which is small a, at index q is equal to 2. And what you are looking at is, what is the matched string now? What is the prefix that you have now? It is null string only. Okay, now the prefix is null string, so nothing is a prefix here. And you are going to see whether the next simple is a prefix. For that, that must be same as the simple. So you are actually comparing the next simple which can be a possible simple for the prefix. Till now the prefix is epsilon and the length is 0. So what should be the next highest length prefix? Of length 1. So what can be that? We are checking whether that is the next simple. So actually you are checking the next simple after the present prefix. Present prefix is null string, so the next simple is b. If b is same as the newly opened simple at the pattern is what you are checking. Now it is not the matching. So when you have the present prefix length as 0, you can set the new value of pi k as 0, which means that there is no proper prefix of BA which is also a suffix of BA, and that is why we are getting it as 0. Now we are going to open the next simple or look at the next simple. What is it? Small b. What is the prefix that you have now of length 0, which is epsilon? Now you are looking at what you have at k plus 1. K plus 1 is 0 plus 1 is 1, which is b, which is same as the newly processed simple at q. So k plus 1 is index 1, and what you have at k plus 1 is b, which is same as what you have at q. That means now you can extend the prefix which is now of length 0 epsilon, which you can extend with the newly found simple. Okay, so what you can basically do is you can increment k. Why? Because now you are getting an increased length string matching, because there is a new match found, and you set pi k as 1. Now you verify that it is correct. When you say that pi q is 1, meaning what is the value of q now? Q is 3, right? You are saying that P3, what is P3? BAB is having a length 1 prefix which is also a suffix. What is the length 1 prefix of BAB? Length 1 is B, which is also a suffix of BAB, is what we are looking at. It is correct, and so the value of pi 3 is 1 means the length 3 prefix, the length q prefix of P is having a prefix of length 1 which is B, which is also a suffix. Okay. Now you extend. Basically you are looking at the next simple after the current prefix. So what you have at k plus 1 is A, and whether it is matching with the newly processed simple from P, which is at q is 4, and you are getting a matching now. So we already have seen what to be done. Increment k and set pi q as 2. Verify that it is correct. Now you are saying that P4, which is when q is equal to 4, you are looking at PQ, which is P4. P4 is BA. When you say that P4, the pi 4 is 2, that means P4 is having a length 2 prefix which is BA, which is also a suffix of P4, and that is correct. So assigning the value as 2 is correct. Proceeding, you are computing, you are checking whether the next value, now the matched string is BA. What is the next value? At k plus 1 is B, which is not same as the newly processed simple at q. But in this case, k is greater than 0. Now this is a pivotal step in the algorithm. What you can do? You cannot extend the present prefix. For that, the present prefix is BA. If you extend, you will get BAB, but unfortunately BAB is not a suffix. This is not B. Now you can observe that now the next possible match will be the largest prefix of BA. Okay, and that is represented by pi k. So what you need is, you need to set k as pi k, because if the present simple is mismatching with the next simple after the prefix, then the largest possible prefix is actually BA only, and the length of BA is 2, which is given by pi k. Okay, sorry, the pi q. So you are updating this as pi k, k as pi k, the largest prefix of BA, that is the value. And so when this happens and k is greater than 0, we found that what you have to do is, you have to set it as pi k. Okay, that is what we did. Now we are going to the next simple. Compare the simples at k plus 1 and q. Now you are not getting a matching, but the value of k is 0. That case is already decided. You have to set pi q as k, which is 0 itself. Now go to the next simple. Now you are getting a matching. When you are getting a matching, you know that you have to increment k, which becomes 1, and assign it as pq. Okay, and verify that. Now you are saying that T7 is having a length 1 prefix, which is also a suffix, which is correct. Extending, now you see that there is a match. So what you do, increment k and assign the new value of pi 8 as k plus 1. And the moment you say pi 8 as 2, that means P8 is having a length 2 prefix, which is BA, which is also a suffix. Yes, that is correct. Now progress. Now again you can see that there is a match. At k plus 2 you have B, which is same as what you have at PQ. So you know what to do. Increment k and assign it as PQ. So now you said pi 9 is 3. What is the meaning? P9 is having a prefix of length 3, which is a suffix. Okay, which is correct. Now we can look at the algorithm which I copied from the text and which do what we observed. M is the length of the pattern and pi is the array to which you are going to store the values of pi that we just computed. And if you recall, the initialization was the length of the matched prefix is 0 to start with, and if you are looking at the first simple, the proper prefix must be of length 0. This is the initialization. And after that we said we have to find the values of pi q for all q from 2 to m, and in the algorithm we are just writing whatever we observed. If k is greater than 0 and there is a mismatching, we said k must be updated as pi k, because that is the maximum possible match possible. And if a match occurs, we said increment k and after that assign pi q as the new value of k. So this is exactly what we observed, and it is written by the authors as the compute prefix function for a pattern. And here I am leaving as an assignment the analysis of this algorithm using aggregate method of amortized analysis. You can prove that the complexity is this. Now we have everything set for looking at the Knuth-Morris-Pratt algorithm, which I copied from the text. Only 2 statements are there. Don't get worried about it. We are going to see what the algorithm is doing. N is the length of the input text and M is the length of the pattern, and pi is the array to store the prefix function on P, and we are just invoking the method that we looked at to find the value of pi. So you are obtaining the values of pi in the array. Now what is Q? A variable representing the length of the highest prefix of P, which is also a suffix of the processed part of the input text. So you are going to start processing the input text from index 1 to n. And until the prefix length is greater than 0 and a mismatch occurs, this is what we need to do, that we observe from the computation of the value of pi q for all q. That is, if a mismatching occurs, this is how you have to update. Okay, you have to thus find a matching prefix. Okay, the highest possibility may not be giving you a prefix, you have to repeat until you get a matching. And if a match occurs, you know that you have to increment the value of q because the matched string can be extended, and you can keep on doing it. And when q becomes m, that means you are getting a prefix of length m in the input text. That means you found a matching. So what you do, you say that now I found a matching. So you print I minus m as the shift. This is what we observed in the basic, in the first lecture where we discussed about automata based string matching. If you find a matching at index I minus m is the shift that you are looking at. Okay, now you are updating q as pi q. Why? Because you cannot have a possible match larger than the pattern, because pattern is what you are looking at. So what you can do? Then the next possible match is actually given by pi q, which follows from the definition of pi, which means if you want you can recall what is the definition and see that it is correct. Now I am giving you a homework exercise to prove the correctness of this KMP matcher, and I am also giving you an assignment for you to analyze this algorithm and to see that the complexity is theta of n. When you do a sequence of operations, we are basically doing an aggregate amortized analysis, we can prove that it is theta of n. Okay, thus we are getting an amortized cost which is linear in the number of input symbols in the text. So today we finished our discussion on the KMP algorithm for string matching. Thank you.